Good afternoon to all our participants out there, and welcome to the Macmillan Maths Hour. Um, we are so honored and so excited on this very hot, warm day on a Monday to come to you with hot news from the 21 Acts of Goodness in partnership with Macmillan. The Old Mutual Foundation launched the 21 Acts of Goodness to enable the matric class of 2020 by providing some much needed extra support and encouragement to all our matriculants. Now, let me tell you this, when the Old Mutual Foundation launched the 21 Acts of Goodness project, Macmillan literally grabbed the great opportunity to support the class of 2020. Today, we want to specifically show all our matrics attending this maths revision session that with their very important final exams around the corner, yes, I know you started with life orientation today and I hope it went well, Macmillan will always have your back. All the 21 Acts of Goodness partners are there to support you, as well as your teachers and your parents. If you are struggling to apply your knowledge in maths, you are definitely at the right place this afternoon. A warm welcome to the session. And before I go any further, I want to highlight, we know you can do well in maths this exam. We've got a control panel on your screen. You can set your options to test your audio, as well as you have a little icon that will actually indicate to you, it looks like a little wheel, we call it a waffle on the right-hand side, where you can download all the material that we are going to use this afternoon. So when you want to do revision at home, you are more than welcome to download this, revisit the information, and upskill yourselves. Furthermore, I would like you to invite you to become interactive with us. We cannot talk to you in different ways, but Sejo will talk to you, and your opportunity lies with the chat function. You see the arrow there? That's where you can type a question. You can make a comment. We will share some links with you in the chat box. So please, all the participants out there, please join us and become interactive. Now, it's my privilege to introduce to you our host for the afternoon, our trainer. I could actually call him teacher, lecturer, facilitator, Sejo Matlala. And you know, an experience of 23 years can take you a long way into project management roles. He is a mathematics lecturer and a PhD student at the University of Johannesburg. So yes, you might meet him next year when you enroll for your further studies. And Sejo is also part of the Macmillan Teacher Campus family. We concluded a one-year contract as a project manager in charge of learner support programs. I know all the learners are close to Sejo's heart. Sejo, I want to welcome you as well, and I want to hand over to you, and I want to say, please enjoy the session and share your love for mathematics with all our participants out there. All the best for the session.
Thank you, Martha. Good afternoon to everyone. Welcome to this session. The session will focus basically on the first part of trigonometry, and then we will continue tomorrow at this time with the second part of trigonometry. Since the session is based on trigonometry, it is important firstly to note or to define the term trigonometry. I know at this time the majority of you might be familiar with the term, but just to recap, what is the meaning of the term trigonometry? Trigonometry is a Greek word. It is made up of two words, which is triangle and metron. So triangle is a triangle that we all know, that we are all familiar with. And the metron is a Greek word that refers to measurement. So in trigonometry, we basically deal with triangles whereby the focus is on measuring the length of the sides of the triangles. as well as measuring the sizes of the angles in the triangles. So trigonometry is basically the study of triangles. That's why then in these two sessions of trigonometry, part 1 and part 2, you'll notice that now and again, I'll be referring to triangles. Now and again, we will be referring to lengths of sides and lengths of angles. Okay, I think that gives a clear meaning of what trigonometry means. But now we know that at school, we do trigonometry. But then what is the purpose of this trigonometry? So trigonometry, we're going to use them in different fields. That is why currently it's important to familiarize yourself with trigonometry. You are now in grade 12, and the majority of you next year will be pursuing their studies. I know that already the majority of you have applied. But then if you apply to one of these fields, the engineering fields, the music fields, surveying, economics, pharmacy, chemistry, and so on, in one of your modules or in one of the sections, in one of the topics that we will be doing, they will need the knowledge of trigonometry. So trigonometry it's very important because it is a foundation to what you will be doing, provided you're going to pursue your studies after the grade 12, whereby I know that the majority of you definitely are going to proceed with your studies. Okay, in trigonometry, you remember that the calculator use is very important. So most of the problems in trigonometry, they will need you to use a calculator. But then the advice is that use the calculator that you normally use in your classes and when you practice. So in the examination, don't get a new calculator to use, the one that you are not familiar with. You rather use the calculator that you normally use when you practice maths and even at your school. So because if you bring a new calculator, you might not know all the functions on that calculator into the examination. So make sure that you familiarize yourself with one calculator that you know that this calculator I'm going to use in my examination. And then one tip also is that when solving trigonometric equations, you know that in trigonometry, at one point, you'll be asked to solve trigonometric equations. So when you solve the trigonometric equations, the advice is that round off only in the final answer. During the calculations, the advice is that do not round off, because once you round off, the rounding off is going to influence your final solution. So you rather stay with the full numbers as they appear on the calculator screen. And then one important thing is that check that your calculator is in the degree mode, that is the DEG mode. Remember the previous night or an hour before, you might be working with your calculator and the calculator might be in another mode. Just make sure that your calculator is in the degree mode, because in trigonometry, we work only with degrees. So if your calculator is not in degrees mode, so the answers that you're gonna get will not be in degrees. Okay. Remember to ask questions if you have got any questions. Remember to ask questions in the chat box. Okay. Then what is the cast diagram? These are one of the tools that are needed when you do trigonometry. The cast diagram is very important. We discussed the calculator, that the calculator, it must be the calculator that you normally use in your classroom or when you practice maths. That's the first thing. Then the other thing in trigonometry, you must be very familiar with the cast diagram, because in most of the problems that we do, the cast diagram is very important. And what is this cast diagram? I know that the majority of you now are familiar with the cast diagram, and that is the cast diagram. Cast comes from the word that in the first quadrant, in this diagram here, in the first quadrant, all the ratios are positive. By the ratios, I'm referring to sine, cosine, and tangent. So the cast means that in the first quadrant, all the ratios are positive. In the second quadrant, which ratio is only positive? The sine ratio is only positive. So in the third quadrant, which ratio is positive? The tangent ratio is positive. And in the fourth quadrant, which ratio is positive? Only the cosine ratio is positive. And that gives us the acronym CAST. So that is basically very important. And these are the basics of trigonometry. And I've also included it in this diagram here. So sine is positive in the first quadrant, cosine is positive in the first quadrant, tangent is also positive in the first quadrant. So you can see that in the first quadrant here, in this quadrant, all the ratios are positive. That's your first quadrant. That's that quadrant there is your first quadrant. And then moving into the second quadrant, which ratios are positive? Only the sine ratio is positive. And then this one is your third quadrant, and which ratio is positive in the third quadrant? Only the tangent ratio is positive. And then the others will be negative. Then in the fourth quadrant, as I've said, only the cosine ratio is positive, and that is your cosine ratio. And then I've indicated here that the cosine ratio will be positive in that quadrant. So it's very important. These are just the basics of trigonometry. You cannot do trigonometry without the knowledge of the cast diagram. Please feel free to ask questions if there is anyone who would like to ask questions. Remember to ask the questions in the chat box. Ne? All right. So the other basic thing regarding the cast diagram is what is called SOHCAHTOA. So I've got the SOHCAHTOA at the bottom here. You see the SOHCAHTOA there, which is also very important. SOHCAHTOA. What does that SOHCAHTOA mean? S stands for sine. The S here stands for sine. What does O and H stands for? It means sine. The ratio for sine is opposite divided by hypotenuse. The K means cosine. The cosine ratio, the ratio is adjacent over hypotenuse. The tangent ratio is opposite divided by adjacent. So this is just an acronym that will help you to remember. Alternatively, others then will use what is called cha-cho-tau. That's your cha-cho-tau. Cha-cho-tau means it means that adjacent over hypotenuse is cosine, opposite over hypotenuse is sine, opposite divided by adjacent is tangent. So those are the basics. I'm highlighting them here so that when we do the actual problems, you are all familiar with the tools that are needed for you to do the trigonometry. Okay? Okay, that is all regarding the cast diagram. Now, I want us to try the following activity. I would like us to try the following activity. Yes, Shamila, your messages will actually come through. If you ask your messages in the chat box, they will definitely come through as I'm reading this one now. Okay, let's look at activity 1. Who can read that question for us? Okay, I'm just going to read it for you. Remember in the examination, it is very important that you read the given statements. Don't just go straight into the questions, but read the statements that are given very carefully, because some of the answers can be found in the given statement. Then I want us to read what is given here. It says, in the diagram shown, I'm going to show you the diagram. In the diagram shown, so that is the diagram. You can all see the diagram. The question says, in the diagram shown, what is happening in that diagram? P is the point 8 and 15. So the coordinates of P are 8 and 15. Where? In this given diagram. That's your diagram which is shown. That's your given diagram. What are the coordinates of P? Coordinates of P are 8 and 15. Here is the point P on the diagram. Remember, I'm saying it's very important that you read the given statement. Why is it necessarily important to read the given statement? Because some of the solutions are lying in that given statement. And also it is given that the size of angle POQ is equal to A. And where is the angle POQ on the diagram? Here is the angle POQ. So it says the angle POQ is A. And you can see that the diagram is a right-angled triangle because angle Q is given as 90 degrees. Now, from this diagram, from the diagram which is given here, the diagram is OPQ, which is a triangle. Now, if you look at the point P, what are the coordinates of the point P? They are 8 and 15. 8 and 15. So 8 will represent the x-axis, correct? So that's your 8, that's the point 8. The point 8 represents the x-axis. This will be the point 8. So that means that OQ is 8. And then PQ is how many units, learners? Will be 15, correct. That will be 15. That's 15 there. You see that I'm still breaking down what is given to me in this diagram. The coordinates of P, they are 8 and 15. But then these coordinates, 8 and 15, means what? It means that the length on the y-axis, meaning PQ, it's 15. What about OQ? OQ will be 8. So these numbers I'm getting them from where? I'm getting them from the given point P. I haven't yet read the questions. I'm just breaking down the statement. And then you can see that there is a side which is unknown. This side is unknown. The side OP, it's unknown. This side here, it's unknown. OP, we don't know the size of this side. Remember what is trigonometry? Trigonometry is the study of length of sides in a triangle, measurements of angles in a triangle. So that is why the sides of these triangles are very important. Now, what are your questions? The questions are that we must determine the length of OP, or you must determine PO. You see PO on the diagram? That's the side that I noted with a question mark, this side. What is the length of that side? After that, you must now find what? You must now determine the length. You must now determine the value of cos A. That's question B. What is question C? Question C, you need to determine the value of tan A plus 17 sine of A. All right. So you have got the given information. You did study all the information which is given, and then you transferred all the given information into this diagram. Now you can answer the questions. And then the first question is to find the length of PO. The next question is to find the size of cos A. Question C, you must find the value of tan A plus 17 sine A. Can anyone tells me how will you find the size of the side PO? How will you find the side of the length of PO? You can just write down the answer in the chat box. Okay, I see. Thank you so much. I got the answers. You are very good. I can see. Some are saying Pythagoras, others are saying distance formula, yes, by using Pythagoras. Or Kopanse says yes, by using Pythagoras. Michali also says by using Pythagoras. And who else? Italy, Zimoto already gave us the answer. The length of PO is 17 units. Let's see what others got. Did you all got 17 units? Bongani says we can use the theorem of Pythagoras. That's very good. Thank you so much for all the answers. All right, let's look at the actual answer. What is the size of PO? Let's see what I got here. The length of PO. Okay, that's 289. PO squared is 289. So your R is 17, meaning that your PO is 17. And then cos A, you see that cos A will be X divided by R. Where comes X divided by R? Remember cosine, the ratio for cosine is what? Is adjacent divided by hypotenuse. So cos A is 8 divided by 17. Remember we had the sides here. And what happened here that erased my, remember that this one we said is 8, that one we said is 15. And then your OP we said is 17. That's what we had here. So it is clear that your cos A will be 8 divided by 17 from the diagram. Remember, we are using the diagram. We are not using the calculator. From the diagram, then cos A will be 8 divided by 17 because cosine is X divided by R. And then what is the value of tan A plus 17 sine A? I hope everybody got the answer correct. The answer is 16 and 7 divided by 8. Okay. Thank you so much for participating in this question, in this activity. Let's get to the next activity now. I hope this is easy for everyone. Just gonna clear up everything there. Okay, these were the solutions for that activity. Those are the clear solutions for that activity 1. I'm not sure if there is anyone who still has a question regarding activity 1. how we arrived at the answers. If there are no questions, okay, let's move to the next activity. Remember, my tip is that read the statement. Make sure that you understand the statement. Do not understand the value of the statement. Remember, it's important to read the statement because some of the answers will lie in the statement. Don't just start by answering the questions. Ne? All right, let's read the statement. If cos theta equal to -7 divided by 25, that's cos theta. It is given that cos theta is -7 divided by 25. And theta is an element of 180 degrees and 360 degrees. So this information, it's very important because it will help us in answering the questions. You can see that it is given that cos theta is -7 divided by 25. Now, because it's -7 divided by 25, the cosine ratio, as it is given here, is -7 divided by 25. So it means that cosine is negative. So cosine is negative in which quadrant? Cosine will be negative in which quadrant? We know that cosine is negative in the second, is it the second quadrant? The third quadrant as well as the second. So the cosine ratio is negative in the second quadrant and the third quadrant. Okay, Mahala, yes, you said the third quadrant, but also the second quadrant, okay? And now this theta here means it says 180 degrees to 360 degrees. So this theta here represents which quadrants? It represents quadrant 2 and quadrant 3. So your theta here says theta is between 180 degrees and 360 degrees. So there are two things here. You know cos theta is negative in the second and the third quadrant. The interval here says second and third and fourth quadrant. So we must calculate the value of 14 tan theta. What is the value of 14 tan theta? That's what we must find with the aid of a diagram. Remember, a diagram must be a triangle because trigonometry is the study of triangles. We mustn't use a calculator. Henry Moroka, you say we're going to use the third quadrant. Thank you so much, Henry. We're going to use the third quadrant. Thank you so much. So the diagram will be in the third quadrant. And what will be the value of 14 tan theta? Please try it and then send me the answer in the chat box. What will be the value of 14 tan theta? That's 48. Thank you so much. So the answer is 48. That is what I got also here. I see Henry got 48. So 14 tan theta is 48. Thank you so much. So -48. Henry, why do you say it's -48? It must be +48 because it's -24 divided by -7. Remember the tangent ratio, it's adjacent, it's opposite divided by adjacent. So you know that the y value is minus 24. That is what we calculated. The y value is minus 24, which is what we have just calculated. Thus the y value is minus, y is minus 24. So this is minus 24. It must be minus 24 because below the x-axis, the y values are negative. That is very important. Remember here, we used Pythagoras. We said y squared is r squared minus x squared. We are using Pythagoras because we are given x. The x value is minus 7. Then the y value is negative 24. The hypotenuse is 25 as is given. So using the Pythagoras theorem like we did before, then we get y as negative 24. Remember, y it can't be positive 24 because y is positive on the other side. I think the person who gave us negative 24 might have used yeah, that's very good, Zimonto. Is our r always positive? That is correct. Our r is always, it's always positive. R, remember, is the hypotenuse, so r can never be negative. I think maybe Henry got negative 48 because he assumed that the y is positive 24, but y must be negative 24. I think that is clear now to everyone. All right, thank you so much. You are doing so well. You see, Hassan is saying it does not give me any access. I think the technicians will sort that out for you. They will attend to your problem. Thank you so much, Azane. Okay, do you have any further questions on this question? Remember, these questions are very important, and these questions are the type of questions that you'll see on the first part of the question paper. Around question 6, somewhere there, you will have the trigonometry questions. So these are some of the questions that you need to know. And then you can see that in activity 2, the diagram was not given. So in some cases, you need to draw the diagram on your own. So in the other cases, the first activity, the diagram was given. Remember, in this case, what made us to draw the diagram in this quadrant is because cosine is negative in the second quadrant here, in the second quadrant, as well as in the third quadrant. That's where the cosine ratio is negative. But now, why didn't we use quadrant 2 and use quadrant 3? We use quadrant 3 because of the interval. Our interval says from theta equal to 180 degrees to theta equal to 360 degrees. And we cannot take quadrant number 4 because in quadrant number 4, cosine is positive. But now the given sign of cosine is negative in this case. Thank you so much. Yes, Langa, we answer here. If when we ask questions, Langa, yes, you will answer it here. Langa, you are very good. Thank you so much. That is the chat box. That's where you answer the questions. I think we have exhausted this activity. Let's move to the next activity now. Before we move to the next activity, I want us to remind you of trigonometric identities. Remember, what is an identity? An identity is something whereby the left-hand side is the same as the right-hand side. So there is a balance between the left-hand side and the right-hand side. So we have got trigonometric identities. Trigonometric identities, they mean that the left-hand side, what is on the left is the same as what is on the right. So I want us to look at the trigonometric ratios. So one of the trigonometric identity which is important is that sine squared A plus cos squared A equal to 1. This is very important. And I think the majority of you grade 12s, you all know that sine squared A plus cos squared A equal to 1. At this stage, everybody knows that even if I wake you up in the middle of the night, you'll know that sine squared A plus cos squared A equal to 1. Remember, you can make any of the ratios here the subject of the formula. Remember that. From saying sine squared A plus cos squared A equal to 1, note that you can make any of the ratios the subject of the formula. So sine squared A will be equal to 1 minus cos squared A. And what about if you make cos squared A the subject of the formula? So cos squared A will be 1 minus sine squared A. So here is that we are allowed to make any of the ratios the subject of the formula. That is correct. Remember, we are using the ratio which is given. The father ratio, the mother ratio is this one. Sine squared A plus cos squared A equal to 1. And from that father ratio, mother ratio, then sine squared A equals 1 minus cos squared A, or cos squared A equal to 1 minus sine squared A. You need to know that by heart. Are proofs of trigonometric identities examinable? No, the proofs are not examinable. You just need to know that sine squared A plus cos squared A equal to 1. Thank you so much. I think that answered your question. Okay, let's move on to another identity. Tan A equal to sine A divided by cos A. This ratio is also very important. Tan A equal to sine A divided by cos A. It's very important. You cannot get into an examination without remembering that tan A is sine A divided by cos A. And of course, this will be the same as when we say tan squared A equal to sine squared A divided by cos squared A, which is that one. So from here, we can say from tan A equal to sine A divided by cos A, we can also say tan squared A equal to sine squared A plus cos squared A. So those are the same. All right. Just gonna clear that. Reduction formulas. The reduction formulas are, remember, I'm giving you the tools so that when we do the activities, we know what the tools are. The identities are very important. And there are basically two identities that are important. Sine squared A plus cos squared A equal to 1. Tan A equal to sine A divided by cos A. That is very important. The reduction formulas. Reduction formulas, what is the purpose of a reduction formula? A reduction formula is a formula that assists us to reduce angles. You can reduce angles bigger than 90 degrees by using the reduction formulas. So with the reduction formulas, what is important is that you must know in which quadrant a particular reduction formula lies. There we are. (180 degrees minus theta is in which quadrant? The reduction in which quadrant? 180 minus theta is lying in the second quadrant. Then 180 degrees plus theta is lying in which quadrant? It's in the third quadrant. Then 360 degrees minus theta is lying in which quadrant? That is the fourth quadrant. Thank you, Azane. Thank you, Azane, for sending the answers. You're doing very well. So it is very important here to know in which quadrant is a specific reduction formula. See that one? 180 degrees. Because remember, your theta in this case is an angle that is between 0 degrees and 90 degrees. So you can see that if you say 180 subtract any angle that is between 0 and 90, the angle will fall in here. It's very important that you know in which quadrants are the reduction formulas. So 180 minus theta is in the second quadrant. Remember, if you want to test that, take, for example, 30 degrees. Say 180 minus 30. What do you get? 150. So you see that 150 will be in the second quadrant. So, and you can see that if your 180 is here, that is the 180 on the Cartesian plane. Once you say 180 minus, you see that it will fall into this quadrant, in the second quadrant. But if you say 180, this is 180 minus, it will fall in here. But from here, 180 plus, then it will fall in the third quadrant, because now you are saying 180 plus, you are continuing, you are adding, so it will fall in the third quadrant. So that's one way of reminding you in which quadrant is a specific reduction formula. You see that? So what about 360 minus? So 360 minus will fall in the fourth quadrant, because remember here it's 0 degrees or what? 0 degrees or 360 degrees here at this point here. We've got a 360 degrees here. My hand here is not writing so well. That's 360 degrees, it's here. That's your 360 degrees, remember. So now if I'm saying 360 minus, it will fall in here. Okay, so that's what I'm saying here, that 180 minus will terminate in the second quadrant. That's for your notes. And 180 degrees plus theta will terminate in the third quadrant. And then 360 minus theta will terminate in the fourth quadrant. And remember, here we use these reduction formulas together with what? With the ratios. Say, for example, if I say the sine of 180 minus theta, so you'll say sine ratio in the second quadrant. Then what will be the value of, say, for example, I want to know from you this one. Type it in the chat box, please. The one that I'm writing here. What will be the value of the tan of what? Say, for example, 360 degrees minus theta. What's the value of 360 degrees minus theta? 360 degrees minus theta. Yeah, you can minus theta. So will the answer be positive or negative? Quickly, just give me the answer. Will the answer be positive or negative? The value of negative tan theta. That's very good. That's very good. You are doing very well. Mihlali, Azane, Henry, Orekopantse, Quirin, Makomoncho, Joy, negative tan theta. How do I reduce large angles like 720, for instance? Yeah, Italy, that is very good. For 7, I'm just trying to answer Italy so quick now, but we're going to do examples. Italy is asking the question, how do I reduce large angles like 720, for instance? Yeah, for angles that are bigger than 360 degrees. You are all listening to me, ne? For angles that are bigger than 360 degrees, you keep on subtracting 360 until you get an angle that is less than 360. So, for example, on 720, you reduce 720, you subtract 360. So you'll say 720, I'm pressing my calculator here, 720 minus 360 equal to 360. So you see that 720 is equivalent to 360. So say, for example, here, I'm just going to jump in there now because The question has been asked. Say, for example, what is the value of the sine of, I'm just going to write it here. I think everybody can see that is the sine of, say, for example, 520 degrees, 520 degrees. You see that this angle is bigger than 360 degrees. I'm answering Atali's question. It's bigger than 360 degrees. And what did I say? You take your calculator, then you say what? 520 minus 360. What do you get? 520 minus 360. Do it on your calculator. 520 minus 360. Ne? What do we get? You get what? The sine of? Good, very good. 160. Yeah, good. You get now 160. It's the sine of, I'm gonna write here. Don't mind my handwriting. So this is the sine of 160. I see everybody got the answers correct. Irene, Mapwane, Asane, Michali, Itali. Yeah, you said it's 160. You see, so it means that the sine of 520 degrees is equivalent to the sine of 160 degrees. Then, okay, now you know how to reduce 160 degrees, which is sine 20 degrees. Very good, Michali. So actually 520 degrees is in the second quadrant and then is equivalent to the sine of 20 degrees. Thank you so much, Michali. So sine 160 is actually the sine of 20 degrees. Remember, I don't mind my handwriting, but I think you can see what I've written here, which is the sine of that. Okay, Italy, that is how we reduce angles that are bigger than 360 degrees. Any angle that is bigger than 360 degrees, if you want to reduce it, you keep on subtracting 360 until you find an angle that is less than 360 degrees. How do I answer questions? 1 to 180 minus 20. No, Italy, then you can't go on. After you got sine 20, then you stop there, because the aim of using reduction formulas is to do this, is to get an angle that is less than 90 degrees particularly. So once you get an angle that is like sine 20, then you stop there, because 20 degrees is now like between 0 and 90 degrees. 160 degrees is in the second quadrant. That is correct, Azani. Good. So let me give you another reduction formulas. I'm just going to erase everything here so that my screen is nice and well. All right. Good. Here now. Okay. Remember, the ratios remain the same. What do I mean when I say the ratios remain the same? I forgot that. Here, when we mean the ratios remain the same, I mean, for example, the sine of 180 degrees minus theta. The answer will be sine theta. You see that it doesn't change. Sine remains as sine. The cos of 180 degrees plus theta will be equal to negative cos theta. So the ratios remain the same. All right. And then now, let's move to the next reduction formula. That is very important. Okay, these ones are very important. The cofunctions, 90 degrees minus, 90 degrees plus, 90 degrees minus theta, 90 degrees plus theta. Where will 90 degrees minus theta terminate? 90 degrees minus theta terminates in the first quadrant. There you are. 90 degrees plus theta terminate in the second quadrant. And this is very easy because this is your 90 degrees. That's where lies the 90 degrees. And then once you say 90 degrees minus, it will fall here, because you are now subtracting 90 degrees minus, it will fall there. But once you say 90 degrees plus, 90 degrees plus, then it will fall where? In the second quadrant. That's your 90 degrees plus. But then, this 90 degrees minus, 90 degrees plus, they are referred to as cofunctions. So the ratios changes to co-functions if you use the 90 degrees plus, the 90 degrees minus. Langanani, how do we answer this? Langanani has just asked a question. I'm reading your questions as we proceed with the lesson so that one person doesn't start. How do, Langanani is saying, how do we answer this? Sine theta plus 180 degrees. Who can answer, Langanani? Langanani, let me answer you. Langanani, that sign is sign of, you are saying, I'm writing it here, it's sign of theta. That's what Langanani is asking. He's asking, how do we answer this? Sine of theta plus 180 degrees. That's the question from Langanani. Theta plus 180 degrees. That is the question. Langanani is asking. Yeah, you see, Langanani, the order is not at 360. Remember, we had provided the angle is bigger than 360. Let's say, for example, 560, 400. This one, Langanani, that question is similar to, here the examiner just changed the order of the numbers. Langanani, you should make 180 the sum, so you just change the position of, good, yes, that's true. You just change the position of theta, Langanani, like this, 180 degrees plus theta, and I know that, yeah, that's very good. I see Ore Kopanse already, oh sorry, I thought you said minus. Yeah, no, you are saying 180 degrees and not minus. That is very good. And then the answer is negative. You see, Langadan, you just change the position. You know, the aim of the examiner is to, this is minus. Yeah, I think that's minus. That's minus sine of theta. That's very good. Yeah, that is good. That's good, Asane. That's minus sine. See, that's how you will do that. I forgot that the thing here, N. So you see, we have just changed the position because the examiner here was just trying to trick you, starting with theta, but it's the same. It's 180 degrees plus theta. Okay, Joy, I'm gonna answer that one. Joy is asking us another question here. It says, what if it was sine theta minus 180? Joy, can I answer Joy immediately there so that Joy is relaxed? What if it was sine theta minus 180? Okay, let's answer Joy quickly. What if it was minus? That's okay. For Langanani, I think you are sorted. You are happy with the explanation that we gave. No? Thank you. And let me answer Joy. Joy says, what if now is theta minus 180? I'm just going to put Joy's question here. Joy is asking, what if is sine? Yolanda, you raised your hand. I'm not sure if you are allowed to speak. Maybe you can just post your answer in the chat box. I think I'm just going to answer Joy's question. You take the negative outside of the bracket. You're going. It will be okay. Let me answer it myself here. It's sine. I'm gonna just tell you something. It's a negative angle, ne? Sine of theta minus. I'm just answering Joy's question quickly. Sine of theta minus the 180 degrees. So this is what Joy is saying. I see that someone is saying, hello? Is somebody speaking? All right. I see someone at 360. Yeah, that is very good. Mateta, Makhonchane. Yeah, you just add 360. Yes, Samkelo. And Makhonchane. That's very good. That's what I'm gonna do. Okay, Joy, like Samkelo and Makhonchane, as they are saying, you continue to add 360 degrees. Remember, if it's an angle bigger than 360 degrees, we subtract 360 until you get an angle that is below 360 degrees. But if it's a negative angle, like the two learners, Samkelo and Makhonchane, you now add 360 degrees until you get what you are used to. So that is very good. That's what I was gonna say. So you'll say equal to the sine of, you'll see after adding 360, now you'll see something that you are used to. It will be sine of, what is this now? What is minus 180 degrees plus 360? Take your calculator there. And minus is minus 180 degrees. Subtract, no, we say we add, because it's negative, we add, plus 360. What do you get? 180. Yeah, good, very good. Good, Asane, Langanani, that's good. We get 180 degrees. Very good. That's 180 degrees, positive 180 degrees. And then your theta is positive again. So that will be plus theta. So now this one, you know it very well. 180 degrees plus theta. Remember, this is plus sign, your plus theta. And then now, this is what we all know. Joy, this is what we all know. And then what is the sign of 180 degrees plus theta? Is it negative or positive? Negative. Good, good, Asani. It's negative. Negative. Good. Negative, the sign of it. Why is it negative, the sign of theta? It's because 180 degrees is found in the third quadrant. So that is how we deal with negative angles. That's very good, Quiren. Is in the third quadrant. 180 degrees plus theta is in the third quadrant. That's very good. So that is how we reduce the negative angles, Joy. You see, if it's just theta minus, once it becomes theta minus, once it's a negative angle, remember, add 360 degrees until you get, thank you, thanks so much, Joy, you are welcome. You're welcome, you're welcome. It's the sine of 180 degrees plus the theta. Thank you so much. All right, okay, let's proceed. I'm just gonna erase here. Let me erase my board so that it's clear. I'm gonna erase it here. All right, good. So these are the core functions. I was just saying, talking about the core function. Okay, Michali, in the exam, do we need to show the calculations where you add 360? Michali, it's not necessary as long as you know the final answer. It's not necessary to show the calculation, but it's always better to show everything that you write. But I don't think you will be penalized for not showing that I've added 360, I've subtracted 360. Okay, this statement here, the 90 degrees minus the 90 degrees plus, remember the cofunction of sine? We all remember the cofunction of sine. So say the sine of 90 degrees. I'm just giving this as an example. The sine of 90 degrees plus theta, okay? This will be equal to what? Asani, cos theta. Is it cos theta, sine of 90 degrees plus theta? Will it be equal to cos theta? What do you think the answer will be? Sine of 90 degrees plus theta. Is it minus cos theta? Positive cos theta. Okay, that's very good. The answer is positive cos theta. That's good, Langadani Mwiponi. That's positive. Good. So I'm going to explain to you why is it positive. So the answer here is positive cos theta. The answer is now positive of cos theta. Remember, these things are very important because when you do the actual problems, you can apply this. That's positive cos theta. And then we are saying positive cos theta because you are saying sine in the second quadrant. Remember, 90 degrees plus theta is in the second quadrant. Sine in the second quadrant is positive. So the cofunction must also be positive. That's why we are saying positive sine theta and not negative cos theta. But what will be the value of this now? Say the cos of 90 degrees plus theta. What will be the answer? The cos of 90 degrees plus theta. Good. Negative sine theta. Yeah, this will be negative sine theta. Why negative sine theta? Most of the students, they struggle with this. Why do we say this is negative sine theta? Because 90 degrees minus theta is in the second quadrant. The cosine ratio is negative in the second quadrant, so the cofunction must also be negative. That's very good. Yes, Kirin, base cos is negative in the second quadrant. Good. Cosine is negative in the second quadrant, so the cofunction must also be negative. Remember that you don't when sketching your right angle and have determine the quadrant in which it is supposed to be in. How do you know if the base should be on the vertical or horizontal axis of the Cartesian plane? Miponi, I'm not sure what your question refers to. Let me read what Miponi is asking him. When sketching your right angle and have determined the quadrant in which it is supposed to be in, how do you know if the base should be on the vertical or the horizontal? All right, Miponi, you are referring to the diagrams. No, the base doesn't matter. It can lie anywhere. Miponi, the base doesn't matter. It can lie anywhere. It can lie anywhere. It's not important. You can draw it like this. It doesn't matter. Let me just clear this so that I can explain to Miponi quickly. If you have got this, I'm just gonna show this. I think that's what Miponi is asking here. If you have got this ray here, say you put the ray, that's your ray, né? And then you can take this from here, from this point, you can move like this. It's all right. It's fine. Another person can do this. The answers will be the same. They will not differ. From this point, so you can go this way. It doesn't matter. Say, can you repeat what you said about the cofunctions, Utlutleng? Okay, I'm just gonna repeat Utlutleng what I've said about the cofunctions. Okay, Miponi, I think you are right, ne? Yes, this one will be your R. You see that your R is from the origin? That's your R. This one also is your R is from the origin. So it's the same. Okay, yeah, thank you, Miponi. All right, if somebody is saying, Utlutleng is saying we must repeat what we have said about the cofunctions. Utlutleng, what? I think Miponi, I think you're fine. Yes, sir, thank you. All right, thank you, Miponi, that's good. Yes, yes, the R will always be from the origin. Just make sure that your R is from the origin. That's very good. That's very good. About the cofunctions. About the cofunctions, yeah, I'll also go to the negative. Like Langanani is asking me we'll go to let me repeat what I've said about the co-functions, but because there's somebody here who asked me to quickly repeat what I've said with the co-functions. I think the student missed some information on the co-functions. It's Otloteng, yeah. Otloteng, what I've said here with the co-functions, I said, say for example, you want the sine of, I'm just gonna repeat what I've said. Is the sine of, say 90 degrees, minus, no, I'm just gonna use plus theta, because 90 degrees here, like this. Please, my handwriting equal to, yeah. So what we say, Otloteng here, the first thing that you need to know is where is 90 degrees plus lying? 90 degrees plus here is lying in the second quadrant. 90 degrees plus is lying in the second quadrant. Now, you can see that we are using sine. Because of the 90, then it means that this ratio sine must change to its co-function. And what is the co-function of the sine ratio? The co-function of the sine ratio is cosine. Then you write cos. Okay. Now, the problem is this. You must decide whether this is negative cos theta or it is positive cos theta. It is positive cos theta because 90 degrees is in the second quadrant. And in the second quadrant, the sine ratio is positive. So the co-function must also be positive. The same applies, for example, if I can get, say, the cos of, just explaining again here, say the cos of, I'm going to use 90 degrees plus, 90 degrees plus theta. So remember, 90 degrees plus theta, we said is in the second quadrant. Now, good, like this one. Now, here is cosine in the second quadrant, ne? So cosine in the second quadrant, is it positive or negative? It is negative. So the co-function also must be negative. And what is the co-function of the psi of the cos ratio? It's sine. So that's where the trick lies. And I know that this raises confusion in most of the students. So you will remember that, you'll remember very well that you check where the reduction formula is lying, and then the co-function of cos is sine. But then, because this is in the second quadrant, and in the second quadrant cosine is negative, the co-function must also be negative. I think I explained that clearly, Utluteng, unless if you have got any further questions. Utluteng, I think you are fine now. All right, Langanani is asking something which is also very important, I think. It's very, so I'm gonna address it now because I address the questions as we proceed so that I don't forget your questions. Langanani is asking this question. Let me first erase negatives. Let me first erase this here, erase all drawings here. Langanani is asking us this question. Say, how about sine squared 360 degrees minus theta? I get confused when theta is squared. All right. Okay, let me explain it to you like this, Langanani. Say you have got, I think your question relates to this, because yeah, this is very important. Say you have got, you are asked to find the sine of sine squared Remember the questions are coming, yeah, sine squared 360 degrees, sine squared 360 degrees, no, it's 360, sine squared 360 minus theta. I think that's what you are asking here, Langanani. What if we have sine squared 360 degrees minus theta? Yeah, this is a good question, like the good questions that you have asked before. All right, to this something like this, if you have got something like this, do it like this. Do it like this. This is the same as, you will write sine. Okay, that's your ratio sign. It's good, it's there. You write the ratio sign. Sine, that will be the sine of 360 degrees. 360 degrees, sine 360 degrees, right. Sine 360 degrees minus, I'm rewriting, theta, that's squared, ne? Right. But then remember, it is squared. It is squared. So you do this. You square all these guys here. Square them. All squared. You see where the square comes in now. All squared. See, Langanani? It was sine squared. Sine squared. It was sine squared 360 degrees minus theta. Then make it easier for you. You write it as sine of 360 degrees minus theta all squared. You see? And thereafter, what do you do now? You will now say 360 degrees, guys, is in the fourth quadrant. All right. 360 degrees minus theta is in the fourth quadrant. And what is sine in the fourth quadrant? Sine in the fourth quadrant is negative. Negative what? Negative the sine of theta. Negative the sine of, here I'm going to put sine of what? The angle in question is theta. Remember, you're doing what? It's all squared. Square it. Square there. I still have my square there. You see? There you are. So is sine squared 360 degrees minus theta. Say, do yourself a favor, simplify it, sine of 360 degrees minus theta, then you put the square bracket, is all squared. Then you work with what is inside the brackets. Remember the basic mathematics law. First start with the inner things, which are these. So sine in which quadrant? Fourth quadrant. Sine in the fourth quadrant is negative. But remember, your squared must always come in there because you have got that squared there. Now you will say this. Minus sine theta all squared is what? It's minus sine theta times minus sine theta. So you are squaring this negative. Negative 1 all squared is positive. So your answer becomes a positive sine squared theta. There you are now. So anything with a square, you will do it like this. Even if here it can be a cubed, it can be sine to the power of 4, whichever has got an exponent, then you will work it out in this way. I think, Langanani, I've tried to answer your question. And I don't know if you still have anything that is not clear to you. You can ask a follow-up question if there is. Okay, thank you. Thank you, Langanani, if you understood that. All right. Okay, let's go on with the reduction formulas. Okay, we did the normal reduction formulas, we did the co-functions, and then we are not yet done. Let's see the others. But the others, I think, is what we did already. I'm just going to show you what I've explained already here. See, 360 degrees plus, assume that it's in the first quadrant. If it's 360 plus, assume that if it's a negative angle, you assume the fourth quadrant. And then this is what I've said. I think the basic one is this one. For angles greater than 360 degrees, subtract 360 until you have an angle in this interval. This is what most of you were asking. This is what most of you were asking. Actually, this statement is a follow-up from these two. From that, yeah, it's a follow-up. So basically, you can actually even ignore this. If it's 360 plus, it's in the first quadrant. If it's minus, it's in the fourth quadrant. But now, this is what we have discussed. I think I've discussed this in detail with you. For angles greater than 360 degrees, subtract 360 until you have got an angle in this interval. All right. For negative angles, you add 360 until you have got an angle in the interval 0 degrees to 360 degrees. Trig identities are examinable, Moiponi. As trig identities are examinable. You need to know the trig identities. You need to know the reduction formulas. You need to know that. Yes, they are examinable. They are in the exam. You must know that sin squared theta plus cos squared theta equal to 1, tan theta equal to sin theta divided by cos theta. Yes, those ones are examinable, including the reduction formulas. They are also examinable. Thank you. I erased that. So let's move to the next explanation or the next question. Activity 3. Question 1. All right. What's the question? Prove that sine to the power of 4x plus sine squared x cos squared x divided by 1 plus cos x equal to 1 minus cos x. Prove that this expression equal to this expression. When the question says prove that this equal to this, it means that we must show that what appears on the left-hand side is the same as what appears on the right-hand side. All right. And to do that, the advice is that try to start with the side which is more complicated. All right. Start with the side that is more complicated. Remember here they say prove that this side, the left-hand side, equal to the right-hand side. Then the advice is that simplify the other side, meaning the side that is more complicated. And from this question, the left-hand side is the side that looks more complicated. Sine to the power. I see somebody's hand is raised. I'm not sure if you are allowed to speak. If you can speak, Makon Chanshu, your hand is up. Oh, okay. So if you have got any question, please send it in the chat box rather than talking over here. All right, here then I say that we're gonna show that the left-hand side is the same as the right-hand side. All right. So we start with a side which is more complicated here, and it is clear that the left-hand side is the side which is more complicated than the other side. Okay, let's see if we can all go through each and every step and understand each and every step. Okay, the left-hand side, that is correct. And we agree that we're gonna simplify the left-hand side here. Okay. We agree that we're going to simplify the left-hand side. Why do we choose the left-hand side? Because the left-hand side is the side which is more complicated. So you start by simplifying the side which is more complicated to get the side which is less complicated. Okay. So when you look at this left-hand side, sine to the power of 4x, meaning the numerator. Look at the numerator. Looking at the numerator, you see that you can take out the common factor. The common factor is sine squared x. That's your common factor. Remember that the advice here is to work with sines and cosines. And one of the tips with these problems is just see if you cannot take out a common factor. Please write down this somewhere. If you have got something like this, take out a common factor where possible. You'll need to factorize. That's one way of proving that one side is the same as the other side. Check if you can't factorize. And in this one, it's clear that we can factorize. So we take out sine squared x. Then you'll say sine x squared x goes into sine to the power of 4x. It goes sine squared x. That's the answer. And then the sine squared x again into sine squared x, cos squared x. So here is the same as sine squared x, cancelling sine squared x. Then you are left with cos squared x. Notice the sign. The sign is plus. That's plus sign. So the plus sign must still come. All right. And that is divided by 1 plus cos x. Okay. All right. Okay, then what must we do now? I think there is something that you can see after we did that. Remember, we said you take out the common factor. I've taken out the common factor, and then inside the brackets, you get sine squared x plus cos squared x. Then what is the value of sine squared x? That's very good, Mihlali. Convert the cofunctions into 1. Convert the identities. Henry, you said the answer is 1. That's very good, Henry. Henry Moroka says sine squared x plus cos squared x equal to 1. That's very good. That is what we need to know there. Sine squared x plus cos squared x equal to 1. Then I've replaced sine squared x plus cos squared x by 1. Then what do I have now? I've got sine squared x multiplied by 1. Okay. Is there anything that we can do further there? Let's see what we can get now. How do we move forward now? It seems we can't move on. Sine squared x divided by 1 plus cos x. Remember, this left-hand side must give us what? 1 minus cos x. What will be our next step? Let me see. Then multiply by 1 minus cos x. Muiponi, that's very good. Change sine x to 1 minus, change. Somebody's saying, okay, Muiponi, that's very good. We can multiply by 1 minus cos x, which is what I did. But I see that here, Quirin is saying change sine squared x to 1 minus cos x. Yeah, that is very good. That's very good. Asane, 1 minus cos 2x might not work. but replacing sine squared x to 1 minus cos squared all squared, that will work. Okay, you are all correct, but Asani, I don't think that will work. 1 minus cos 2x, 1 minus cos 2x is a double angle, and here we don't deal with double angles. But what Orekopan says is good. Asani says trig identities, but not 1 minus cos x. So I followed the route that is suggested by Muiponi, which is fine. And what Quiren is saying is also fine. But remember, if you use Quiren's suggestion, 1 minus cos x, remember to square it, Asani. That's very good, Asani. Yeah. All right, you are referring to 1 cos squared x. Yeah, that's very good. That's very good. Yeah, you are right. But then I followed the other method, which is still good. And your method of replacing, I like that method of replacing because sine squared x, you know already that sine squared x will be 1 minus cos squared x, and then you're gonna factorize. But one way is to do this. That's what you can do. You rationalize like the denominator, what we loosely say. You say multiply by 1 minus cos x, 1 minus cos x. Here you didn't do anything here because you multiplied by 1. Remember this one, if you divide 1 minus cos x, divide by 1 minus cos x, you get a 1. So you didn't do anything here. You just multiplied what you have by 1. You only multiplied what you have by 1. That is what you have there. And then moving forward, now, what will you do? You've got that. I'm just going to erase that thing there. Let me just remove this. That's what we have. So I'm just multiplied. You see, 1 plus cos x multiplied by 1 minus cos x is 1 minus cos squared x. Remember, you just multiply like you multiply, say, for example, x plus y. No, let me get this. This is just straight multiplication. Say x, let me just use this, a minus b. Say multiply by, I'm showing you how you can multiply that thing. 1 plus cos x multiplied by 1 minus x is similar to multiplying a minus b, a plus b, a plus b. This is the same thing. That's the same thing. Yes, it's the same thing. You see. So what is a minus b? A plus b. When we multiply the two, you get a squared minus b squared. Minus b squared. So that is the same thing, correct? That's the same thing. You are still there. So that will be 1 minus cos squared x. 1 plus cos x multiplied by that. You just multiply the numerator, you multiply the denominator, then I've got that one. Moving to the next step. That's what we have. What is 1 minus cos squared x? 1 minus cos squared x, we all know that is sine squared x. You replace that, 1 minus cos squared x becomes sine squared x. But the denominator is the same. Then what will happen? What we like to do? You cancel out. Cancel that. Cancel that. Remember, you are dividing. You are not canceling there. You are dividing, but we loosely say we are dividing. We are canceling. Actually, we are dividing or multiplying. And that is what appears on the right side. And that's what the final. Okay, we get the final answer. And remember, there are many ways of arriving at the final answers, but one way is to follow what I've done here, and that's it. That's how you will simplify that. Okay. Okay, we said, just to go through the problem quickly, said start with the complicated side. Then what did we do? We took out the common factor. Please check if you cannot take a common factor. If you can do that, take out the common factor. Then here, I just replace sine squared x plus cos squared x by 1. All right? Good. And then here, I like rationalize, but we don't necessarily call it rationalization. I just multiply it by 1, because when you arrive here, it's like you are done, you are finished. And then from there, then you'll get that step. This step is the same as this step. So the two steps are just the same. I just multiplied them. Then from there, I get that. Then I canceled out. I get to the final answer. Okay, those are some of the steps that you can follow to prove that. Yolanda, yes, even if you use the laptop, your chat box will be there. I think, can you please someone assist Yolanda how to see the chat box? It seems Yolanda cannot see the chat box. Yolanda, even if you are using the laptop, the chat box will definitely be there. Can somebody, if possible, answer Yolanda in that case? It seems Yolanda says she cannot see the chat box. Can someone assist Yolanda with the chat box?
Yolanda, the control panel will be on the right-hand side of your screen. If it went inside, there's a red arrow that you need to click so that it pops out.
Okay, thank you, Ntlantla. I think Yolanda, please try that option. I think it will assist you because we want to communicate with you. Okay, thank you so much. That is how you will prove that. Let's go to the next question. Question 2. Question 2, still based on the question that we have just done. Question 2, let's see, actually, let me see here. Yeah. Remember, reading is very important. Reading is very important. You need to read the question so that you are able to understand the question, because what you are reading can help you in answering the question. Okay, question 2 is a follow-up to what we have just done. You will see question 2 says, for which values of x? So we must find the x values here. For which values of x is the whole expression not true? They mean we must find the x values for which the left-hand side cannot be the same as the right-hand side. They say, when will the left-hand side not be equal to the right-hand side? Will not be true, will be undefined. It will not be true provided the denominator here, you see your denominator is 1 plus x. Once I make the denominator to be equal to 0, this thing becomes undefined, and then it won't be true. So, sometimes they will ask you, when will it be undefined? But now here, because in undefined, sometimes the question will use the word undefined. When will the right-hand side be undefined? It will be undefined if your denominator, the whole of the denominator, becomes a 0. It will not be true. Okay, how do you show that? Remember, here we are working with trigonometric functions. It's trigonometry here. So how do you find that? That's the solution. The x values for which x plus cos x equal to 0, which are x an element of x. So that's where the answer lies. If say, for example, you say 1 plus, take your calculator, please, and then find me the value of 1 plus cos 180 degrees. What is the value of 1 plus cos 180 degrees? Do it on the calculator. Karen? Yeah, you see that you get a 0. That's very good. Samkelo, Italy, you get a 0. Or Kopanse, Mitlali, Kurena, Zen, Maho, Fanshani. That's very good. You get a 0. So that is why then I'm saying if x is an element of 180 degrees plus k dot this, because the whole thing here gives you a 0 when you substitute x by 180 degrees. So it means that x must be 180 degrees, but then I'm putting k dot 360 degrees because of the revolution. It's not 180 degrees only. It can be 180 degrees, you complete a revolution at 360. So always when you add 360 degrees, you will arrive at the denominator being a 0. So to make it generic, to make it general, then we say 180 degrees plus k dot 360 degrees, because it's not only at 180 degrees that 1 plus cos 180 degrees will be equal to 0. It can be at any angle unless, as long as you complete the revolution of 360 degrees. So that is how we get the answer there. Does this become a general solution? Yes, it's a general solution. Say, say, I don't get how we got to the answer, but how did we get there? Rain, yes. How did we get here? Okay, I'm just gonna explain again. I'm saying that they say for which values of x, né, is this expression equal to this expression not true? It will not be true provided whatever is here, whatever is in the denominator becomes a 0. Because remember, any number divided by 0 gives you what? It gives you undefined. Ne? So this statement won't be true provided what appears in the denominator here, it's a 0. So one way or the other, it means we solve this equation. It means you are solving this. All right, it's just one way or the other. It means you are saying, you said it will be undefined provided 1 plus cos x equal to 0. Then you solve that, you'll say 1 plus cos x equal to what? Equal to 0, ne? All right. Then now cos x equal to what? You take 1 to the other side again. Cos x will be now what? Cos x is now equal to minus 1, correct? Because I took a positive 1 to the other side, guys. I see the responses here. Yes, I'm gonna answer those questions. Okay, it's cos x equal to. So how do you find the value of x now? You'll say x. You use second function cos, ne? Equal to then cos. You can use your calculator. Please take out the calculator and see what you get there. Minus 1 into minus 1. Let me verify with my calculator. I took cosine to the right hand side and then it becomes that. So you say second function, ne? Cos, then the brackets are there, you put minus 1. I'm using mine here. You see it's 180 degrees. It has 180 degrees, that's very good. So that's where the 180 degrees comes from. But now we want it, yes, it says x equal to 180 degrees. But remember, Asani, you cannot just write x equal to 180 degrees because it can repeat itself. Then you say plus k dot 360 degrees because they didn't specify in which region your x must be. So like someone was saying, it's like finding the general solution. Yes. So you see, Mwiponi also explained how did we get the 180 degrees. All right, Corinne, thank you so much. Okay, now it makes sense. All right, thank you, Asane, thank you. So it's just like solving that equation, but remember to make it general, unless otherwise the solutions were restricted, like for example, say for x between 0 and 160 degrees. Then in that case, you won't put it as general, but now we are putting it as general because the question is open. Okay, all right. Let's see let's move on. I see I did not cover what I've done, but I'm happy that you're asking questions and I'm asking and we are trying to answer the possible questions that you don't understand. And then it will be not good just to rush through this and then leaving some of this. Okay, let's go to the next questions if there are no further questions on this one. Activity 4. Yeah. Show that cos of 360 degrees minus x tan squared x all over sine of x minus 180 degrees. Okay, these little dots here, it shows 180 degrees. I didn't write them that well. Please bear with me. Cos of 90 degrees plus x equal to 1 divided by cos x. Show that cos of 360 degrees minus x tan squared x divided by sine of x minus 180 degrees times cos of 90 degrees plus x equal to 1 divided by cos x. Like I've said, you start with the more complicated side. These are just degrees, guys. These are degrees. This thing is so these questions involve the use of what? Reduction formulas, ne? So they involve the use of reduction formulas. So let's see how we get to the answer. Okay. 360 degrees minus x. I think when I was pasting this, it's just changed my degrees. So it's cos of 360 degrees minus x tan squared x divided by the sine of x minus 180 degrees times the cos of 90 degrees plus x, correct? I'm just rewriting the left-hand side because the left-hand side is the side that we must reduce since the left-hand side is the complicated side. Remember the approach here is to do what? Is to work with the side which is more complicated. And then I'm just gonna go on here. Okay, normal. Okay, that is true. Here we say, I'm just gonna go through this. Through this step with you. Cos in the fourth quadrant, because 360 degrees minus x is in the fourth quadrant. Cosine in the fourth quadrant is positive. Correct. Tan squared x, remember, we prefer that you work only with sines and cosines. So tan squared x is the same as what? Remember the reduction formulas? Remember the trig identities? Tan squared x is the same as sine squared x divided by cos squared x. Now, sine of x minus 180 degrees. We discussed this in detail when we were discussing the reduction formulas. Remember, we said for the negative angles, what do? We add 360 degrees. So x minus 180 degrees plus 360 degrees becomes x plus 180 degrees. Remember, we said, I'm just showing you how we are going to arrive on this one. This one here. I'm finding the value of this one. Is a negative angle. Remember, at the beginning, we said at 360. So minus 180 degrees plus 360 will give you this. Then now, usually we want it to be written like this. You just change, you just rewrite it so that you start with X. You start with 180 because we are used to starting with numbers and then the other things later. 180 degrees plus X. Now it makes sense if it's like this. See, because it was a negative angle, that's what we are doing. And then now, so 180 degrees is in which quadrant? 180 degrees is in the third quadrant. In the third quadrant, sign is negative. So this is negative, the sign of X. All right. Negative, the sign of X. Okay, so that is why here, that is why the sign of X minus 180 degrees is minus sin X. The cos of, what will be the cos of 90 degrees plus X? So this one is now a cofunction. So is that 90 degrees plus X is in the second quadrant. Cosine in the second quadrant is negative. So the cofunction of cos is sine. So because the cosine ratio is negative in the second quadrant, its cofunction must also be negative. Right, that step there. And then now, what did I do here? I just simplified here. I simplified here. It's sine squared x, cos squared x. So what we do, what we normally do, cancel out. The cancellation law. Cos x into cos squared x. It goes cos x. So it's sine squared x divided by cos x. Multiply by, remember here you are dividing by positive sine squared x. So we invert that. So it becomes 1 divided by sine squared x. And then the answer, from there you just simplify further again. Then you get 1 divided by cos x. How did you arrive at 1 divided by cos x? You cancelled out those, and then you arrived at that. Right. Unless if there is any question regarding these steps. Any questions disappear? Okay, that's correct. So here, like I've said, you get the left-hand side. These are reduction formulas. You must know what is cosine in the fourth quadrant, dealing with the negatives, dealing with the cofunctions. Then you have that. And then from here, you will cancel out. Remember to change tan into sine and cos. There you canceled. Then you obtain that step. And then from there, you just multiply the denominator. Remember, if you divide, then you change to multiplication. All right. And then I'm going to erase all that and then move to the next question. Next question. Okay, this is the continuation of activity 4. It's a continuation of activity 4. Hence, calculate without the use of a calculator the value of this. So this is from activity 4. And then we said the thing here, if you see here, because if they say hence, it means use what we have obtained before. So that you can change it to this. You see, 330 is in the fourth quadrant. So it's 360 minus 30. So I'm just gonna say, because we want to use the previous question, and this was our previous question, that one. It's our previous question. So you must write this in this format, because we need to use the previous question, since they say hence. Unless if they say hence or otherwise. If they say hence or otherwise, then you can use another method. But if they say hence only, preferably they want you to use the previous question. And that is how you will go about that. And from the previous question, we already know that that statement there was true. This is what is given in the previous question. That equal to 1 divided by cos x. How do we go further from there? Where is the thing now? Normal, I put it there. So that's, you see that now is cos of 360 degrees minus 30, which is similar to that. I'm getting what was on top there. That is that. So you see, this is written in this because the cos of 330 is 360 minus 30. Tan squared 30. Sine of 30 degrees minus 180. Cos of 90 degrees minus plus 30 degrees. So this statement, the two statements here are the same. You see that the left-hand side is the same as the right-hand side. The only difference is that instead of x, we now have 30 degrees. We substitute x by 30 degrees, substitute x by 30 degrees, substitute x by 30 degrees, substitute x by 30 degrees. So on the right-hand side also, we can substitute x by 30 degrees. And then we get what? We get, if we put x here, we get 30 degrees. And 1 divided by 30 degrees is 2 divided by square root of 2. Okay, because of the time constraints, I'm just gonna run quickly through all of the remaining questions, and just to show you what we're supposed to do. But because I think we have managed to cover everything, because we have managed to answer all the questions that you asked. Okay, this is also simplification. Is similar to what we did. Similar to what we did, as you can see. So it's tangent in the third quadrant, cosine in the fourth quadrant, is the use of the reduction formula. And I think now you know how to use the reduction formulas. So the denominator is divide. You see the catch is on the 540. Remember, what will you do with 540? You minus 360 until you get an angle between 0 and 360. This one, what is the value of cos of minus x? That one is very important. What's the answer there? Cos of minus x, cos of minus x. What's the answer there? Cos minus x equal to what? Okay, let me see, the answers are coming here. The cos of minus, good, channel, that's good. Positive cos x, that is very good, because minus x is in the fourth quadrant. Don't say you take out the negative. No, we say minus x is in the fourth quadrant, so cosine in the fourth quadrant equal to positive cos x. That's very good. So you treat all the negative angles, as long as it's minus x, minus theta is in the fourth quadrant. All right. Okay, let's go on then. Just gonna erase there and then get to normal mode. Okay, that is what I did there. Here you can see that now the cos of 540 degrees plus x becomes the cos of 180 degrees plus x. Remember, cos of minus x, remember, if it's a negative number, we said we add 360. So here I've added the 360. I've added the 360. Here I've added the 360. That's why you have got that. And then you go to the next thingy now. You'll have this. You'll have that. You'll have that. You'll have that. You'll have that. And then your final answer is minus sine x. That's minus sine x divided by minus 1, which is minus sine x. So you can, this step comes before. So this step comes here. And then this one must come down. Okay. So I just simplified further from there. And then let me do this. Erase all that, and then guys, I'm just gonna do. Okay, question 6, it was evaluating. You can see that it was got angles that are bigger. You'll use the same method, and then because of time, I'm just gonna run through the solution. So the answer is minus the square root of 3. I think you can just go through the answers. 130 is sine of 180 minus 50 times 60. 540 is 360 plus 180. Then tan of 230 is 180 plus 50. 400 is 360 plus 40. So you end up having sine 50 times 60 equals 180 times 50 sine 40. Then tan 60, you got this on the calculator. Tan 60 is on the calculator. You can do that on the calculator. Tan 60 will give you square root 3. And then cos 180 on the calculator gives you minus 1. And then here, then sine 50 and tan 50 cos 50. And then tan 50 is sine 50 divided by cos 50. Then the final answer is there. Okay. Then now, okay, question 7, it was finding the general solutions.
Dr. Matlala,
Yeah.
I think we can just stop here. Thank you so much, Leonard, for tuning in. Tomorrow we've got part 2 of trigonometry. You want to explain that a little bit, Dr. Matlala?
Yeah, okay. Thank you, Lenas, for taking part in this session. So tomorrow we have got another session, and then in tomorrow's session we will be dealing with the compound angle formulas. So thank you so much for attending. Thank you, Nhlanhla.